Alright guys, in this video we're going to be looking at some kinetic molecular theory questions. I think they're all free response. The graph below shows a Maxwell-Boltzmann distribution for H2. On the same graph, draw the distribution curve for oxygen at the same temperature. Okay, the key part, they're the same temperature, and we are going to be drawing for oxygen. Now, if this is the Boltzmann curve for hydrogen, we would expect hydrogen, which is a smaller atom or element, it weighs less, has a smaller molar mass than oxygen right here. This one only weighs about 2 grams per mole, whereas these oxygen atoms weigh 32 grams per mole. Okay, so they're much heavier. And since they have the same temperature, that means they have the same energy. So overall, in terms of speed versus number of fraction of molecules, we should have a dotted curve that shows more molecules that are moving at slower speeds compared to the hydrogen. Okay, if this is hydrogen, then this dashed line will be oxygen right there. Okay, so that would be a Maxwell-Boltzmann distribution for oxygen relatively. What they're going to be looking for is a higher peak and closer to the left. So as long as you kind of do something along those lines, you should be okay in answering this for the AP test. This one is similar. We have a solid curve line below that shows the distribution of molecular speeds of a sample of gases of VbO2 particles at 165 degrees Celsius. The student incorrectly sketches the dashed line to show the distribution of VbO2 particles when the temperature is decreasing to 135. So explain the student's error in this question. So somewhere along the lines, we got to explain why this dashed line is incorrect if it's supposed to be 135 degrees Celsius, and this one is supposed to be 165 degrees Celsius. So first off, the dashed line is showing that there are now more particles moving at the same speed as before. So that's not really what this curve is trying to show. We're trying to see a difference in temperature change. Well, if we're changing temperature, we're changing the average kinetic energy, okay? Which means these molecules are going to have less energy than the 165 degrees. So we should see a shift to the left with less or more molecules moving at slower speeds because they have less energy. So we should see a shift to the left. So let's see, it should be somewhere over here. Okay, and it would be dashed. But so we need to explain the student's error. We need to talk about how changing the temperature changes the average kinetic energy, and therefore the molecules are going to be moving at slower speeds. So the shift should have been pushed to the left and not above. Okay, finally, the plot shows distribution of particle speeds for equimolar amounts of N2 and element R at the same temperature. Though that's important when you have the same temperature. Based on your plot, is the molar mass of R greater than, equal to, or less than the molar masses of N2? Well, since there's been a shift to this left, okay, that means there are more molecules moving at slower speeds. So I would then say that that molecule R, or whatever it is, the molar mass will be greater than. These are heavier molecules because they are moving at slower speeds. Okay, so something along those lines. You can use the kinetic molecular theory to explain it, but essentially R is going to have a greater molar mass, and that's what causes slower speeds, more particles with slower speeds than N2 since they are at the same temperature.